The invisible structure around you right now. You are sitting inside something you cannot see, cannot feel directly, and were never taught to truly imagine. It surrounds your phone, your walls, your hands. It stretches from every charged particle in your body outward into space, and it never switches off. We call it the electric field. In school, you probably saw it drawn as arrows radiating from a charge, neat lines pointing outward or inward like a diagram in a manual. The picture looked simple, almost decorative, a visual aid, something abstract. But those arrows were never the real story. An electric field is not a spray of invisible threads. It is not a cloud floating around an object. It is not a physical substance leaking into space. And yet, it is not imaginary either. Here is the part nobody emphasizes. The electric field is a condition imposed on space itself. When a charged particle exists, it changes the rules of the space around it. At every point nearby, space acquires a new property, a readiness to push or pull another charge. If one appears, even if nothing is there, that condition remains. The field does not wait for a second charge to exist. It is already present. So ask yourself something unsettling. If you remove every other charge in the universe except one, does the electric field still exist? According to modern physics, yes. That means the field is not merely a description of interaction between two objects. It is something more foundational. It exists even in isolation as part of reality's structure. And this is where the discomfort begins. Because before electric fields were invented, physics believed something far stranger, that objects reached across empty space and pulled on each other directly, no medium, no structure, just influence through nothing. To understand why the electric field was revolutionary, we need to step back to that unsettling era when forces had no explanation at all. The death of action at a distance. Imagine living in a universe where objects can influence each other across empty space with absolutely nothing in between. That was the world of early physics. When scientists like Isaac Newton described gravity, they wrote equations that worked perfectly. Planets orbited, apples fell. Predictions matched observation with astonishing accuracy. But there was a hidden discomfort beneath the success. How does the Earth pull the moon through emptiness? There was no mechanism, no medium, no explanation for how the force traveled. It simply acted instantly across distance. This idea became known as action at a distance, and even Newton himself admitted it felt unsettling. Influence without contact, force without substance. A universe where objects somehow knew about each other without anything connecting them. Electricity inherited the same problem. When Charles Augustin de Coulomb measured electric forces, he found a law almost identical in structure to gravity. Charges pushed and pulled each other according to distance. The math was elegant. The explanation was not. Then came the breakthrough. Instead of saying one charge directly pulls another, physicists began to describe something existing in the space between them. A charge creates a field around itself. That field fills space. When another charge appears, it does not interact with the distant object. It interacts locally with the field at its own position. No reaching across emptiness, no mysterious communication. Only local interaction with a condition already present. This shift was more than semantic. When James Clerk Maxwell wrote down his equations, he showed that electric fields are dynamic. They can change. They can ripple. A changing electric field creates a magnetic field. A changing magnetic field creates an electric field. And those coupled disturbances travel outward through space at a very specific speed, the speed of light. That realization shattered the old picture completely. Light itself is not a stream of particles emitted from a source in isolation. It is a self-propagating disturbance in the electromagnetic field, which means the field is not just a bookkeeping tool. It is something that can move, carry energy, and exist independently of the charges that created it. And once you accept that, a deeper question becomes unavoidable. If fields can move and carry energy on their own, what exactly is it that we've been calling empty space? The field is more real than the particle. What if we've been focusing on the wrong main character all along? For centuries, physics treated particles as the fundamental building blocks of reality, tiny solid objects, little beads of matter moving through empty space. Fields were secondary, useful mathematical tools describing how those particles influenced one another. But modern physics quietly flipped that hierarchy in quantum field theory, the most successful framework we have for describing nature. Fields are not secondary, they are primary. The universe is not made of particles sitting in space. It is made of fields that exist everywhere, and what we call particles are simply excitations of those fields. The electric field is not something created after an electron appears. The electron itself is a localized vibration of a deeper electron field. That idea is radically different from the textbook picture. Instead of imagining a tiny charged bead generating influence around it, imagine space already filled with a field. When energy excites that field in a specific way, a stable ripple forms. That ripple behaves like a particle. It carries charge. It has mass. It moves. But it is not a separate object inserted into space. It is something space is doing. This changes the meaning of the electric field entirely. The field is not a byproduct of matter. It is part of the fabric of reality. Even in regions where no particles are present, the field still exists. It has values at every point. It has energy. It can fluctuate. When we say a charged particle creates an electric field, what we really mean is that the presence of that excitation modifies the surrounding field configuration. Space adjusts itself accordingly. And here is the deeper truth nobody emphasizes. Energy can be stored in the field itself. If you separate two opposite charges, work must be done. That work does not vanish. It is stored in the electric field between them. Even if no particle occupies the space in between, energy resides there. So empty space is not passive. It carries structure, tension, potential. And once you understand that, a new question emerges, one that pushes far beyond classical electricity. If space is filled with fields everywhere, then is space truly empty at distance? Empty space is not empty. Take a region of space, remove every atom, every electron, every photon, strip it completely clean. What remains? Instinct says nothing. Physics says not even close. Even in a perfect vacuum, electric fields still exist, not because particles are present, but because fields are not objects placed into space. They are properties of space itself. At every point in the universe, the electromagnetic field has a value, even if that value happens to be zero on average. But zero does not mean non-existent. Here is where intuition breaks down. In quantum physics, fields cannot remain perfectly still. They cannot sit at exactly zero energy. The uncertainty principle forbids it. Instead, they fluctuate minutely, relentlessly, even in total darkness, even at absolute zero temperature. These fluctuations are not science fiction. They have measurable consequences. Subtle effects appear between metal plates placed extremely close together in a vacuum, a phenomenon known as the Casimir effect. Nothing visible exists between the plates, yet a force emerges because the vacuum itself has structure. The emptiness is restless. This means the electric field is not merely something that appears when charges are around. It is always there, capable of vibration, capable of storing energy, capable of influencing outcomes even when no particles seem present. And that forces a conceptual shift. In high school physics, space is treated like a stage. Matter and energy are actors moving across it. But modern physics suggests the stage is dynamic, flexible, alive with activity at microscopic scales. Particles are no longer independent beads drifting through emptiness. They are stable patterns within fields that never disappear. So what we casually call nothing is actually a sea of potential, a structured vacuum. And if fields define the vacuum and particles are excitations of fields, then perhaps matter itself is not the most fundamental layer of reality. Perhaps fields are. Which leads to the final unsettling realization: what we call forces may not be pushes and pulls at all, but manifestations of how space organizes its own internal rule. The truth nobody tells you. So here is the truth nobody tells you about electric fields. They are not invisible arrows floating around charges. They are not decorative lines drawn to help students pass exams. And they are not secondary effects produced after matter shows up. They are fundamental. When you say a charge creates an electric field, you are using convenient language. What is really happening is deeper. The presence of charge changes the state of a field that already exists everywhere. Space adjusts. The field configuration shifts, and other charges respond locally to that change. No distant pulling. No mysterious reach across emptiness. Only space responding to its own structure. That means force is not a magical interaction between separate objects. It is the result of a field having a certain value at a certain point. When a second charge appears, it does not communicate with the first across distance. It simply reacts to the condition of the field where it stands. This reframes everything. Energy stored between two charges is not hiding inside the particles. It is distributed throughout the field in the region around them. Light traveling across the universe is not a stream of glowing pellets. It is a ripple propagating through the electromagnetic field. Even what we call empty space is not empty. It carries the potential for excitation. It fluctuates, it holds structure at every point. The electric field is not something added to space. It is part of what space is. And once you see that, the picture of reality shifts. Matter becomes less solid. Space becomes less passive. Forces become less mysterious. What you experience as attraction or repulsion is simply the universe following the rules encoded in its fields. The arrows in textbooks were only shadows of a deeper idea. The real story is far more profound. Space itself is not a void waiting for things to happen. It is an active participant. And the electric field is one of the clearest clues we have that reality is woven not from particles alone, but from fields that never truly disappear.